Hello and welcome to the Hydraulics Gen Fam for the Airbus A320. We hope you gain an expanded knowledge base in maintenance and troubleshooting. This instruction is for information and training purposes only. It is not intended to be a substitute for the aircraft maintenance manual and any other publications produced by the manufacturer of the aircraft. Always refer to the AMM, which supersedes any instruction given. Also, you have watched the Gen Fam's of OA video to understand the structure and format of the video instruction and what is expected of you. So what can you expect to learn from this instruction? The learning objectives are the following, but not exhaustive. Number 1, gain familiarity with the general orientation and operation of the hydraulic systems. Number 2, gain knowledge of the applications. Number 3, identify the hydraulic components and their locations. Number 4, gain knowledge of servicing components as well as safety maintenance practices. The sessions are the following. Session number 1, we're going to go over just a general overview of the hydraulic systems. Session 2, the hydraulic controls and ECAM indications. Session 3, descriptions for green, yellow, and blue systems. Session 4, ground surface panels. Session 5, hydraulic reservoirs, including the filling. Session 6, seal drain system. Session 7, EDPs. Session 8, electric pumps. Session 9, monitoring, indicating, and testing. Session 10, the accumulators. Session 11, the PTUs. Session 12, the RAT system components. And our 13th and last session is the RAT extension and retraction operation. So let's go ahead and start with our general overview. Okay, this is going to be our first session. And then we're going to hear Rick's story. Rick is part of our OA instructor team, who's also a 30-year veteran pilot. And we're going to hear it from his point of view of a hydraulic operation gone wrong. Let's identify the systems first, then identify components involved in the hydraulic systems, and then describe their functions. There are 3 main systems and 3 auxiliary systems. There's also the leak measurement systems in place for testing and detecting leaks in all 3 main systems. There are 3 hydraulic systems that are identified by colors, which is different from, if you're familiar with the Boeing 737, we don't have colored identification, but we do have this in the Airbus A320 family. The colors are blue, green, and yellow, or if we want to put this in the right order, we have green, yellow, and blue. The green is for the left, engine, coming from the source of left engine, and then yellow from the right, and blue is the auxiliary. The normal operation pressure, of course, is 3,000 psi to the following applications: your flight controls, landing gear, cargo doors, your brakes, and thrust reversers. The applications that are not used in flight, those are separated out from the main supply of power. Now, what about the auxiliary generation systems? Okay, the auxiliary power is actually coming from your PTUs of the green and yellow system, the RAT of the blue system located in the left belly fairing, and then the electric and hand pumps of the yellow system, and those are located on the yellow ground surface panel. The hand pumps in this system are used to operate the cargo doors in the event that there's no electrical power. So let's go ahead and just take a look at the diagram. You can see here it shows which systems are supplying, to which applications. And the systems, all the hydraulic systems are containing consist of the reservoirs. We have accumulators, and we'll get into detail on each of these later. But we do have reservoirs, your accumulators, the manifolds, which we're going to find a lot of components there, the controls, indicating systems, RAT systems, the PTUs, pumps, and the expected valves. One hydraulic compartment is the main landing gear compartment, which contains the components of the green system. Okay, that's your left side. The other 2 hydraulic compartments, your blue and yellow, are forward of the main landing gear compartment, the left and right belly fairing respectively. The systems are designed to be separated hydraulically. This allows for the systems to continue in case one of them fails. Each of them has a pump which pressurizes each system. The yellow system pump is connected to the right engine, whereas the green system pump is connected to the left engine. And the blue system pump, which is electric, starts automatically when at least one of the engines starts. There are manifolds that are used, and where you will find, again, most of those components. Then this prevents potential damage to the lines when you're doing replacement. So for some of the components, there are also bobbin type connections on the manifold, and that's because you have those different dimensions of the ends. There's also a seal drain system that's responsible for collecting any potential fluid leakage from any of the components, and this keeps it away from the aircraft structure, which, if we find it there, could be a potential fire hazard. After the main landing gear compartment are the 3 ground service panels, one for each of the systems. The blue and green service ground panels are in the left belly fairing, and the yellow in the right belly fairing, and you'll see that on the diagram. The reservoirs for each of the systems are pressurized by bleed air from the pneumatic system and keeps them pressurized at a constant 50 psi. Let's go over a little bit on the inside the flight compartment to give you some orientation with the panels. In particular, we're going to go into detail with the 40 VU and 50 VU right now. I just want to give you an overview. But your 40 VU is going to contain your push-button switches for your engine, different pumps. And then your 50 VU, think about that as your service panel, because that's where you're going to have your ECAM messages. And that's where you're going to be doing some servicing. You'll find those fault messages. So that gives you kind of a general idea with what different components we're going to be talking about, and also the color identification, which, again, if you've never worked on Airbus, would not be familiar until now. So let's go ahead and move on to Session 2. Session 2 is hydraulic controls and ECAM indications. So here, remember I mentioned the 40 VU panel, which you'll find here, and you just take a look at this diagram, you'll see where these are located. The 40 VU has the push button switches for each of the engine 1 pump, the engine 2 pump, as well as the electric pump, which is your blue. Okay, so these are color coded, so you'll see them on there on the display, with green indicating engine 1 pump, and then the yellow color for the right engine, okay, or engine 2 pump, and then blue for your electric pump. You also have your push button switches for the PTU, that's for green and yellow, and then the electric pump, there's another one for yellow, and then your RAT man on, okay, that's your manual. So the 50 VU, that was on 40 VU. Your 50 VU has also push button switches, and what you're going to find here is, remember I mentioned the leakage, you're talking about being able to measure the leakage. This is where we're having those indications. So here we have the controls for the 3 leakage measurement selectors. And again, these are used for servicing only. Also, the other thing you have on the 50 VU is the blue pump override push button. And what this does, it just makes it possible to operate the electric pump when the aircraft's on the ground, okay, and you don't have the engines running. Now let's look at the 40 VU, okay, the 40 VU panel, it's your hydraulic panel. You have engine 1 and 2 pump push button switches. The engine 1 pump obviously controls the left engine, which is your engine 1 engine-driven hydraulic pump, and engine 2 pump push button controls the right engine-driven hydraulic pump. And when the push button is selected to the on position, which means you're going to have those off lights extinguished, they're not going to be illuminated, which means it's on, the pump is going to pressurize when the engine's running. And the associated ECAM indication is a green box with a vertical line. And when you see the green box is a good thing, the vertical, with the vertical line, that means everything's running the way it should be. Now, when the push button is selected to the off, of course the pump is going to depressurize and the off light's going to be illuminated. Okay. The associated ECAM indication is an amber box in this particular case. When we don't have it being pressurized, we're going to, instead of it being a green box with a vertical line, we're now going to see an amber box with a horizontal line. The fault light illuminates amber, so we're going to see that. Of course, amber, you guys are familiar with that, but we're going to see that when we have the reservoir level, basically the fluid's too low. Also, if we have an overheating of the reservoir, we're going to find that amber light come on as well. Also, the reservoir air pressure, if that gets too low, the pump produces a low output pressure. So output pressure of the pump If we have too low of an output pressure, that we're going to also have an amber light. So some of the things that you're going to see as far as the way it's going to be worded on the panel is you're going to have your reservoir low level, okay, your RSVR low, LO, and LVL, your low level, and reservoir overheat, OVHT, your reservoir low air pressure, PR for pressure, and engine pump low, okay, low pressure. So now let's look at the blue. We're talking about the electric pump. And the blue electric pump push button is a guarded push button. It controls the blue electric pump, and it's normally in the auto position. So you're not going to have those off lights on, right? When the push button is selected in the auto position, the blue electric pump is always energized in flight if the AC power is available. And in this position, with the AC power available, the pump will begin to operate on the ground when at least one engine is running. And the ECAM indication with the pump running is a green box. Okay, when things are good, we have a green box with a vertical line. And that's what you'll see here when you have it operating and there's AC available, AC power, and you have, at least one of the engines are running. When the push button is in the off position, okay, that was in auto position, but now what if it's in the off position? Here, obviously the pump's de-energized, and then in this position, of course, we're going to see what on the as an ECAM indication. We're going to see the amber box with the horizontal line. All right, so when we have a fault, the fault illuminates amber, okay, when what? The same conditions are met as the engine 1 and 2 pump, okay, except for the addition of the pump overheat. And we also have the ECAM messages associated with the fault indication being the same as well. We have the electric pump overheat, OVHT, okay? So kind of same thing with what we mentioned for the engine-driven pumps we have for the electric pump as far as the fault indications. Now, what about the yellow? Remember I mentioned it was a yellow electric pump. This push button controls the yellow electric pump. It is normally in the off position. So that means you're going to have your on light extinguished. Okay, in the off position, the pump is de-energized. Okay, that's its normal position. And the pump will automatically energize if we have the cargo door manual selector valve moved. So if that happens, then what? Okay, we have the pump that's going to automatically energize. The operation of the PTU and the flight controls is inhibited when we're having the cargo doors, operate, and just for a short period of time after they cease operation. The ECAM indication is a white open triangle, and that's what we'll see there. Now, when the push button is pressed to the on position, okay, I just explained about the off position. Now we're on to the on position. The pump is energized, and the on light illuminates. The pump remains energized until the push button is pressed again to the off, okay, off position. And the associated ECAM indication with the pump running is a green triangle with a leader line. And here's just a little caution for you. The yellow electric pump will pressurize the flight controls and the flaps through the yellow and the green hydraulic systems. Okay, this is going to be done through the PTU if energized before start. All right, the fault light will illuminate for the same reasons as the electric pump. Okay, blue. Okay, what about the PTUs? Okay, so PTUs, these are normally placed in the auto mode. Okay, when the push button is selected in the auto mode, the PTU will, on the ground, okay, it's going to perform a self-test when the second engine is started. It also will automatically engage when differential pressure between the green and the yellow hydraulic system reaches a predetermined value. When enabled in the automatic mode, the PTU's operation is inhibited when the couple of things. Number one, the yellow system's electric pump is activated, okay, by either the cargo door lever. Also, the engine master 1-2 switches are in opposite positions, and the nose wheel steering is disconnected by the towing lever on the nose gear. And then the park brake is on. So those are two conditions, okay, when we talk about when we have an enabled automatic mode, then what the PTU's operation is inhibited when we have these conditions. The fault appears on the push button when we have a green or yellow system failure. Okay, that could be due to loss of fluid. You also could have an overheat situation. So again, fault's going to appear on the push button when the green or yellow system reservoir has overheated. Or also if you have a low air pressure in the reservoir. Okay, and just kind of a side note, the fault indication is only associated with a green or yellow system malfunction. Okay, just keep that in mind, only for the green and yellow, so your main systems. And then another note, just the PTU, if it, for whatever reason, fails after the automatic testing, the ECAM will not inform the crew. Okay, the crew will be aware of the failure only if there's a subsequent green or yellow pump failure, okay, that occurs. Then the crew can view that on the ECAM HYD systems page. They'll be able to see it then. Okay, and you can see from the diagram, kind of give you an orientation of the position of the different push button switches for engine 1 fire. You'll see that in engine 2 and your blue pump as well as your leak measurement valves that you'll see right next to the blue pump switch. Okay, so you just kind of look at the diagram that shows you where those are located. All right, so the PTU on this, just when selected to off, and the off indication illuminates on the push button, and the PTU is incapable of automatic reactivation. Okay, now let's move on to the Ratman on push button. The Ratman on is used to manually extend the ram air turbine, and it's doing that to pressurize the blue hydraulic system. Okay, so ram air turbine to pressurize the blue hydraulic system. In order to gain access to the push button, its red guard must first be lifted. You have to just lift that red guard up. When it's deployed, the message rat out is going to show up in green on the right side, okay, of the engine warning display memo section. So to think about that, message rat out is going to show. Normally it's Ratman on, but if we have the rat out appears, it's going to be appearing in a green on the right side of the engine warning display. The ECAM hydraulic system page indication with the rat extended, okay, because we're going to talk about that later on the operation of extension and retraction, is a green triangle with a leader line. And the ECAM indication of an inoperative rat is an amber. Okay, that's pretty standard. You guys are familiar with this already, with the amber being obviously there's something not operating correctly. Your rat man on, again, the warning on this one is the activation of the man on push button, even with no power on the aircraft, will cause immediate deployment of the rat, and it can cause injury or death. And just a little side note, in flight, rat extension occurs automatically with the loss of the AC bus 1 and 2. In this case, the emergency generator is also automatically activated. Now, what about the 50 VU? I know that's 40 VU, and we're going to be getting more into the 50 VUs you're servicing. So here you want to make sure that obviously we don't want to have leaks, hydraulic leaks going on, obviously if they're found airplane on ground. We have to address that. So hydraulic leak measurement valves is what you're going to find on the 50 VU panel. Your blue pump override is also on here. It's also located on the 50 VU panel. And what this does, it's providing to allow maintenance personnel to operate the blue electric pump, okay, without any engines running. In the off position, the on light will be extinguished, and then you're going to have the blue electric pump de-energized until an engine is running or the push button is selected to the on. This is the normal position of this particular push button. In the on position, the blue electric pump is obviously energized. All right, so now what about the leak measurement valves? It's going to be, again, measuring or being able to detect and pick out leaks going on in any of the two major systems and the backup and the auxiliary. So the push buttons here are used for maintenance personnel to isolate those leaks in those hydraulic systems. Your normal position, of course, is in the on, so you're not going to have the off light on, it's going to be off. This allows the hydraulic fluid to go to all the hydraulic components in the respective systems. If it's in the off position, okay, so then you're going to have that light illuminated, meaning that it's off. The leak measurement valves are closed in the respective systems, and then you're not going to have that hydraulic fluid, going and flowing to the flight controls. All right, what about engine 1 and 2, your fire push push buttons? These switches are on the overhead. These in particular are on the 20 VU, and they're controlling the motorized valves in the suction lines to the engine pumps. The 3 hydraulic systems, okay, that we have are, obviously we have sensors and switches, and they're just going to be monitoring the condition of those systems constantly. The material that you're going to find on here that's displayed on the lower ECAM, okay, you got a lower and upper ECAM on here, or the system display, and you're going to find those on here. And so what are we going to find? What is it looking for? Well, number one, remember I keep mentioning about temperature. We've got to look at temperature and pressure. So it is going to be monitoring that temperature of the hydraulic fluid. And not just, it's going to be, you know, at the reservoir and also electric pumps. Also, number 2 is the internal pressure of the reservoir. And then also, you know, I mentioned earlier about the output pressure being too low from the pumps, so it's going to be monitoring that as well. Then number 4, the pressure of the hydraulic fluid itself, you know, all together in the systems. And then lastly, the amount of, obviously the quantity of fluid in the hydraulic reservoirs. The information from the sensors that gets sent to the flight compartment, and all of that is used for obviously the fault warnings on the overhead panel. That's also going to be used to deploy any audio warnings, and then also to send illumination to your master caution and master warning lights, okay, or master warning light. And then you also have your, of course, your ECAM displays and your engine warning displays. Now, hydraulic indications on the HIDE ECAM page. Okay, this is normally white. System identification here. The label of each hydraulic system, those are normally white. The triangle system below is green if the pressure is normal. Of course, if it's not normal, what we're going to see, you're going to see that color amber again. And that's obviously, we're talking about when pressure drops below what's normal. Your actual system pressure, okay, what about that? Same thing, no different. It's green if it's good, amber if it's not. Your RAM status indication, you've got that also, and that's showing on the blue hydraulic system. So when you have the rat stowed, an open white triangle indication appears. But if it's deployed and it's doing the deployment successfully, then you're going to see a green triangle with that leader line. And if the rat hydraulic pump is inoperative, then of course you're going to have the amber triangle that shows up on there. And what about your main system pump status? Main system pump, you got your green and yellow systems. Okay, those have the engine-driven pumps. And they're displayed again as a green box with a vertical line. That means everything's good. Okay, amber, of course, we're talking about low. Amber low indication means that engine 1 pump, okay, is on, but you have hydraulic pressure that's too low. Okay, and that's when you're going to see that amber box with the horizontal line that indicates, you know, that the engine 1 or the 2 pump is selected to the off. It means we're going to see the illumination of that off light. Reservoir contents, this is quantity of the reservoir. So we got indicated here by the vertical line with a point on it. Okay, and that point's indicating the fluid level. The indication is considered to be normal when that point is when it's within that adjacent green box. And then the indications become amber, of course, and accompanied by that EWD caution message when the fluid level goes below a certain preset limit. We also have PTU status, your power transfer unit indication. That one is located between your green and yellow systems. Green arrows are pointing away from the PTU. In white indicates that the PTU push button is in the auto position and the PTU is armed, but it's not yet supplying that pressure to either system. So it's just ready to go, but it's not actually providing and allowing that flow of pressure to the systems. Okay, your normal indication with both engine pumps operating and the PTU is not inhibited, is what you would have there as far as conditions. And you'll see kind of on the diagram, you'll see here your engine warning display at the top of the page, and then at the bottom you'll see your system display. You kind of get an idea of, see how it has the different systems from left to right. You're seeing the green, your blue, which is your auxiliary, and then it has your yellow on the right side, which is your right, coming from the right side, right hydraulic system. Okay, and in the middle, you just kind of look at what you've got there. You notice on the, of course, in each of the the system columns, you'll see 3,000. That's our typical system pressure, no matter what aircraft we're talking about. 3,000 psi is your supplying pressure. And of course, you have your PTU indication there with your in the middle. And then you also have auxiliary pump status. And moving down there on that system display, you're going to have pump temperature warning, your fire valve status, RAT status, main system pump status. Remember, I mentioned the reservoir contents. That's actually located right below your main system pump status. And you got also your reservoir pressure warning to the right of that, the far right. And then, of course, your fluid temperature at the bottom right corner of the system display. The hydraulic indications on the HYDE ECAM. Okay, so here we look at PTU status. We're going to obviously have the amber again, meaning that PTU has been selected off, or the PTU it's inhibited, it's not working. An indication with green arrows going right to left. Okay, so from right to left means that the PTU is supplying pressure to the green system. Okay, indication with the green arrows going from left to right means that the PTU is supplying pressure to the yellow system. The auxiliary pump status, on this one here, the indication is normally white, and of course it changes to amber if this power supply there is not working. When the pump is selected to the off position, then you're going to have this open white triangle that shows up on there. If the pump is on and the yellow system pressure is normal, then you're going to have a green triangle with that leader line. If the pump is on and the yellow system pressure is low, then you're going to have an amber triangle. Okay, so green triangle is good, amber triangle, it's not good. Your pump temperature warning, that's going to be also in amber. Of course, your fire valve status, I just mentioned earlier, you'll see that there in the diagram, is indication on the green and the yellow systems. And here you're going to find a green circle, not a triangle in this particular case. So here we have a green circle with a vertical line, and what does that mean? Okay, it indicates that the valve, it's not fully closed. The amber circle with a horizontal line indicates that the valve is fully closed. Now, what about the reservoir pressure warning? The reservoir is normally pressurized to prevent pump cavitation. Okay, so that's pretty clear. We need to make sure we maintain a good constant pressurization to avoid that problem. So the message here, we want to make sure we monitor that air pressure. It's going to show low air press. Okay, and that will appear in amber along with the EWT caution message when, again, that reservoir pressure just drops below the normal pressure. Your fluid temperature warning. The reservoir overheat indication appears in amber. It's going to show there when the fluid temperature goes too high. What about your hydraulic system memo? So memo messages that appear that you're going to see are going to be on the right side of the EWT page, D page for the hydraulic system. And what you're going to see here is going to be HYDE PTU and also your RAT OUT, RAT out, right? Your HYDE PTU message appears in green when everything's running fine. Your RAT out message appears also in green when the RAT's not fully stowed in the flight, okay, in flight, or the RAT out message appears in amber on the ground. And that's just right before takeoff power application in the event that the RAT is not fully stowed. So we can just kind of get a feel for that. Again, looking at the diagram gives you a better orientation as you continue to review that. And what about just briefly on the hydraulic component connections and identification? If you're, again, this is new, completely different configuration with the Airbus compared to the Boeing 737s, even on next gen. We're going to find, you're going to find a lot of the components right on the manifolds, and you're going to have those connections because you're going to have different varying ODs on the ends. You're going to have different dimensions on the connectors. So this is why we have the bobbin type connections. So here you're going to find them on the manifolds. And again, the manifolds are machined to allow, obviously different components to be installed on them. And the type of material here, you got an aluminum alloy castings that the connection between them is, again, is frequently via the bobbins. Bobbin type hydraulic connections are commonly used when components are installed on the manifolds, and they can range in size from 1/4 inch to an inch in diameter. Of course, you're going to need special tooling that may be used for removal and installation of those components, from the manifolds. Bobbin connectors, they have different types of seals on each end. A small groove is cut in one end to identify the manifold size, so you know which one. And the square seal is the one that is installed on the end of the bobbin that goes into the hydraulic component, so that's how you'll know. Okay, so you get a small groove that's cut in one end that identifies the manifold side. The square seal installed on the end of the bobbin that goes into the hydraulic component. And then there's an O-ring seal is installed on the end that's installed in the manifold. And in both cases, the seals have a backing ring to support them. As far as identification, all components in the hydraulic systems are identified by a functional item number, your fins, which are described in the front matter on the A320, 319 maintenance manual. Each of the components are identified on the aircraft with a self-adhesive placard, either attached to the component or the nearby structure. Okay, so that placard is going to contain the nomenclature and, of course, also the fin, the actual number. And you'll see kind of from the diagram, giving you an idea, not all of them obviously, but this gives you just a sampling of the way the identification labels look like and what's, how it's written on there and where they might be, stuck on the actual component. Okay, so you'll see that diagram at the top left corner. For example, there, it's, we have the number, the fin, and then it has a description of the filter reservoir return. Your typical manifold on the right, it's also, you can see the bobbin connection there. And just kind of the way the breakdown is, on one end you got the manifold side where you've got that identification groove. Okay, so that concludes session 2. We are going to go into some knowledge checks just to kind of give you some idea on some of the test questions, because as you saw the GenFams of OA video, you know that there's a test associated with this module. So we'll get into that and help you to reinforce some of this material before we move on to session 3. All right, we are on to session 3, and this is going to be describing the all 3 different systems, your green, yellow, and blue hydraulic systems. Let's go ahead and start with our green system. The green main hydraulic system is just one of the 3. And what is this supplying power to? It's going to be the landing gear and doors, and that includes the nose wheel steering, also the number 1 engine thrust reverser, normal braking system, and some of the flight controls, and also the power transfer unit. It's operating, of course, the nominal pressure is at 3,000 psi. And it's possible to pressurize the high pressure system from different sources. So what are these sources? We have your engine driven pump, the power transfer unit, and also ground supply connections. The operation, of course, is automatic, unless, but the crew can also take some control of parts of the system. The ECAM, of course, is monitoring things as well. As far as the components locations, most of them are installed in the main landing gear compartment for this particular hydraulic system. It's also kept physically apart from the other 2 systems wherever possible. The system's hydraulically isolated from the other 2 systems. It is possible for fluid to go from one system into another. Now, part of the main hydraulic system is going to be 2 subsystems, your high pressure and your low pressure circuits. So your high pressure circuit is going to be that which supplies the consumers. Okay, it's going to be supplying, to the applications, and then your low pressure is going to be your return circuit, through which the fluid returns back to the hydraulic reservoir. The HP, okay, your high pressure circuit, is usually pressurized by the engine driven pump that's connected to the number 1 engine, okay, your left engine. The solenoid valve is operated from the flight compartment by the push button switch, which in turn controls that EDP, the engine driven pump. Pressure switch, you got a Trek valve as well. Those are installed downstream of the EDP. And the pressure switch monitors the output pressure of the pump. Okay, remember I mentioned before, one of the things that the ECAM is monitoring when we're looking at that is the making sure that the output pressure is not too low coming from the pump. So we have a pressure switch that's monitoring that. The check valve, of course, stops the flow of fluid to the pump if there's another source pressurizing the system. Okay, just making sure we don't have a duplicate sources to that. The power transfer unit, that is also pressurized, or can pressurize the high pressure circuit. It also gets its power from the yellow main system. It supplies power to the green system automatically. And here's the critical pressure. Okay, remember we have to maintain a system pressure at 3,000 psi, but if for some reason the system falls below, let's say to 500 psi, okay, so that's going to be a trigger right there. So it supplies power to the green system, okay, automatically if that system pressure falls to that 500 psi below the pressure in the yellow system. Okay, there's no hydraulic connection between the two systems. Okay, so fluid cannot get from one system to the other in that case. Now on the ground, it's possible to pressurize the system through the ground supply, and you have the self-sealing connections for a ground supply that's installed on the ground service panel. The HP manifold, remember to mention, but you get high pressure. And I'm going to talk more about the high pressure manifold and low pressure manifolds. But here, the high pressure manifold has ports, and those connect, which connect it to the other parts of the system. The system pressure inlet has a filter with a filtration rating of 15 microns. There's also a check valve to stop the flow of fluid in the reverse direction. And then you can just get a feel for the orientation or feel of the applications that the green hydraulic system provides that hydraulic pressure to. And the diagram shows at the top left, you'll see that you have the yaw damper, pitch trim, rudder, and an elevator. Okay, you got slats, ailerons. Okay, this is on the left side, left hand. Spoiler, spoiler 5 and spoiler 1. And then kind of center, you'll see also right hand slat and the ailerons, and then spoiler 5 and 1 right hand. And then also the nose landing gear doors, so it supplies pressure to there for that actuation. And the nose wheel steering. Okay, main landing gear doors, like I mentioned earlier. So just kind of look at the diagram and just see kind of how it flows there, and the kind of the position of things, the position in relation to one another, kind of give you a good orientation of what's happening there. Okay, and then also with this we have the pressure relief valve. So besides the check valve, we also have part of the green hydraulic system. We have a pressure relief valve. And what is that? Okay, that's protecting the system from overpressure, right? The two pressure switches and a pressure transducer are also installed on that high pressure manifold so that it can monitor that pressure and not have it, have too much pressure out there. There's a sampling valve also that's installed on the HP manifold. And what is that? Okay, that's possible to, basically it makes it possible to just take samples of the fluid from the system for analysis. Okay, so it's very important to, I've talked about hydraulic fluid before and just the importance of having quality hydraulic fluid and not have a contamination or any kind of corruption to the integrity of the fluid. So here's an opportunity here with the sampling valve to have the samples of fluid taken. So then we also have the system accumulator, and we'll cover that in a session by itself on accumulators. But here you have a system accumulator, and it has a direct hydraulic connection to the HP manifold. It keeps basically the pressure in the system free from small changes. It also makes the supply of fluid available to replace any temporary shortages. Kind of like a Johnny on the spot, amount or a supply of hydraulic fluid in case, there's a shortage or whatever, it's there. And that can happen if there's a sudden large demand all of a sudden. Because remember, the airplane's constantly, right, there's just all these variables going on all the time. So, it needs to have almost like a backup, but that's what that is. It's just being able to provide that in case there's an extra demand for that. There's also a solenoid valve on the HP manifold that controls the flow of fluid to the LMS manifold. Okay, so that's operated from the maintenance panel that you'll find in the flight compartment. And so what does this LMS manifold do? It makes it possible to measure the internal leakage of groups of the user systems. Okay, that supply is divided into 3 separate outputs. Okay, so what are the outputs going to? Okay, so we got flight controls in the left hand wing. We also have flight controls in the RH wing and flight controls in the tail section. The main system is connected with the power transfer unit through the PTU manifold. So there's a manifold for the PTU, and that also has outputs to other, other applications. There's also, again, on that PTU manifold, just like we have on the other HP manifold, we have the solenoid valve on it. And that solenoid valve installed on there controls the flow of fluid. So what's its job? Okay, it's controlling the flow of fluid to and from the PTU, right? There's just a single switch in the flight compartment that controls the operation of those two solenoid valves. So one switch for two, okay? So when that is operated, when you operate that switch, then it's going to actually energize both the solenoid valves, and then that's going to supply, it's also control and operating the supply of fluid to and from the PTU. And when you operate those things, it's actually going to stop that flow to or from the PTU. There's also the system priority valve, and that's installed on the PTU manifold, and that's going to stop the supply of fluid to non-essential users if the system pressure is too low. There's two check valves that are installed in the PTU. Those are just controlling the flow of fluid, right, in the manifold. It's pretty simple there. Okay, so now let's look a little bit more with the green, this green main system. It's supplying the following, okay, direct from the EDP, okay, that's upstream of the priority valve. The left-hand engine thrust reverser, okay, that's the number one engine thrust reverser. And then from the HP manifold, what is it supplying to? It's supplying to the left and right hand spoiler 1, and also left and right spoiler 5, and then also left and right on ailerons, the slat wing tip brake, your flap, elevator, rudder, trimmable horizontal stabilizer, and the yaw damper. And again, seeing the diagram just shows the listing there in a kind of a, again, just to break out what those are. And then from the PTU, for as far as where that's, supplying, and that's going to be supplying for the nose wheel steering, the nose landing gear and doors, the nose landing gear doors, and also the main landing gear and doors, and then also the slat power control unit. And then from the PTU, the normal braking system is going to be, actuated. Okay, and I just kind of, again, referring to the diagram gives you a better orientation of what is supplying, to, like, which applications are being supplied by the green hydraulic system. And now we're going to look at or just talk about the low pressure circuit. Okay, that's the return of fluid from the applications, right, to back to the reservoir. You've got K streams for the EDP and also for the PTU, and the returns from the HP manifold, and all of that are also connected to the LP circuit. Okay, to the low pressure circuit. The circuit has check valves where applicable to control that flow of fluid. And remember, those check valves are there to protect the system in case there's a leak in those subsystems. Some of the return lines are connected together at the LP manifold. Okay, part of the LPs is also used in the reservoir filling system, and we'll get a little more detail. There's quite a bit to just explain about reservoir filling when we get to that session. We'll go into detail on that one. So what about from here with the low pressure circuit? As far as the flow of hydraulic fluid, okay, that's actually going to go through a filter, because remember, we want to have it filtered obviously before it goes into the reservoir. We want to make sure we don't have a contamination of that fluid into the reservoir that's going to go to, obviously, to the systems, the user systems. So we have this filter. Okay, it's a filtration rating on this filter is a 3 micron rating, and so if you have this filter element that's clogging, then a bypass operates, and then you have unfiltered fluid that's going to the reservoir. So it's going to get there, but if for some reason the filter element is not it's clogged up, it's still going to allow that fluid to go to the reservoir. There's also a temperature sensor that is attached to the outlet of the LP filter, and that's going to monitor the temperature of that return fluid. Okay, and then, of course, that information is going to be sent to the ECAM, and then give you kind of warning indications there in case it's too high. You also have another filter that's installed in the EDP case drain line that goes to the LP system, and that particular filter is actually a 15 micron rating. You also have the reservoir itself that is installed in the main landing gear compartment. Remember when I mentioned in general overview your green hydraulic system components? Those are for the most part going to be in that main landing gear compartment, and so that's where you're going to find the reservoir. That's going to hold a supply of fluid, and just make sure you follow the AMM as far as the actual specific quantity of that fluid. But it holds a supply of fluid. It also makes those allowances for any differences of the quantity of fluid in that system, okay, because of little just positions of whatnot when actually filling that reservoir up. There's also the reservoir filling system that's operated from the ground service panel. Okay, remember how I said each of the ground service panels, there's a ground service panel for each of the systems. So here we have a ground service panel strictly for the green system. So that's where you have that. There's a reservoir drain valve that's also installed on the reservoir. You're going to find that in all the other systems as well. The reservoir has a drain valve. Okay, now the question is, what pressure? I know I mentioned this before in the general overview, but the ideal pressure, the operating pressure for the reservoir is actually at 50 psi, and that's just enough to prevent the cavitation at the inlet of the EDP. Okay, that supply of air comes this is pressurized with air. Okay, that supply of air comes from the aircraft pneumatic system. That's where it's coming from. It's also possible to pressurize, of course, from a ground supply. Now, along with that, it's typical with any hydraulics, truly just about any hydraulic system, you guys already know probably, but you're going to have a depressurization valve. That's also installed on the ground service panel, but you do have that depressurization valve. And then the PRV and air pressure gauge are also on the reservoir. There's also a motorized valve. That one is installed in the suction line between the reservoir and the EDP. Okay, and that operates when the engine fire push button in the flight compartment is operated. Okay, that's when that gets activated or gets going. And what it does is stopping that supply of fluid to the EDP, if there's a fire. So I'm going to make sure that if there's a fire in the nacelle, it's going to make sure we're not going to feed that by having that fluid available. Okay, so just in general with the green hydraulic system, when we look at the operation of it, you can stop the automatic operation because it is automatic. It is possible to stop that, but let's kind of start this with the EDP. Okay, that starts to supply the system as soon as the engine starts, right? And you're going to have the same situation with number 2 engine. Okay, when we get to the yellow hydraulic system. So here the supply is continuous. Okay, so it's not like an at-demand thing. It's just continuously supplying that. The EDP pressurizes the system. Okay, fluid at the 3,000 psi, and it changes its output to that which is necessary for the system, right? Because not all is needed, as far as 3,000 psi. It's just what's available there to provide whatever is necessary for each of the user systems. So here again we have the system accumulator, okay, that makes allowance for any kind of decrease in the pressure. Also, if the EDP stays in the high output configuration and there's no demand, let's just say there's no demand, then there's an increase in pressure in the system. And so what happens when you have that, which we don't want, you're going to have that pressure relief valve open, and that's going to allow the fluid to go to the reservoir through the PRV. Okay, so pressure regulating valve. And then the restriction to the flow caused by the PRV causes an increase in the temperature. Okay, and that temperature is going to be picked up by the sensor on the LP filter, and of course that's going to translate back to the flight compartment, right? So, and then what if the pressure in the green system decreases? Okay, so we know we could go up or down, right? So too much pressure, or we have too low a pressure. So the magic number, okay, a PSI is 500. If it decreases to 500 PSI, less than the pressure in the yellow system. So just so you know, we're doing a comparison between the green system and the yellow system. Okay, so if the pressure in the green system decreases to 500 less than the pressure in the yellow system, then you're going to have the PTU automatically kick in because it's going to need that boost. Okay, so that's going to pressurize that green system to roughly the same pressure as the yellow system. We're just kind of keeping an equalization between the two systems pressure. The condition of the system is monitored, of course, continuously. We're going to look at temperature and the pressure sensors. All of that's, information is going to the flight compartment, and of course that's going to show up on your ECAM and as fault warnings, and that's going to be on the overhead panel. All right, and the diagram, again, I'm just kind of referring to the diagram. If you just keep looking at that, getting you oriented with, what the user systems are being supplied by the green hydraulic system. Okay. Also, just back on the 40 VU, because remember, that's where you got those push button switches here for the systems. You have the two switches on the overhead panel, okay, the 40 VU, controlling the operation of the green main system. So here, of course, you got the, your switch controls the solenoid valve in the EDP, and it gets energized, and the EDP is isolated from the high pressure system. Okay, so it's keeping the EDP connected to the suction line, and that's keeping an internal pressure, which is just enough for lubricating the EDP. Then you have another switch. Okay, remember, so there were two pressure button switches. The other one controls the two PTU solenoid valves, and when you remember, I said it just takes the one switch to operate two, so one for two. So when that gets operated, okay, that switch, then both of those solenoid valves are going to be energized, and then you're going to have the PTU isolated from the two systems. There's also a pressure button switch at the rear of the overhead panel on 50 VU. Okay, I was just describing on 40 VU. Now, what is what's relevant on 50 VU as it pertains to green hydraulic system? Okay, so here at the rear of the overhead panel, 50 VU. That controls the solenoid valve of the leakage measurement system. Okay, because that's going to be important to know if there's leakage, right? And of course that switch is obviously operated by you guys. Operation of the fire valve, okay, that's, again, it's going to allow the crew to stop that supply. The biggest threat, of course, to the aircraft is going to be fire, so we want to make sure that we're not continuing this potential fire hazard by continuing that flow of hydraulic fluid. Okay, and as far as the symbol on there, you're going to see that as HYD. Okay, symbol on the HYD page, and then page of the ECAM display shows if the fire valve is open or closed. Okay, so that's what you have there. Okay, so that kind of gives you an idea with the green. Okay, that the green's your left system, the left hydraulic system. Giving you an idea of what the user systems are that the green hydraulic system is supplying power to. And kind of getting a feel for the high pressure circuit, low pressure circuit. We're going to see similarities, obviously, between that and the yellow system. And then when we get into the blue hydraulic system, which blue is like your backup there, it'll be a little bit different there, but at least it gives you an idea with that. Now, let's go ahead and talk to kind of describe the yellow hydraulic system. So what is this supplying power to? Okay, in comparison to what we had earlier. So here it's going to actually operate the cargo doors. You've got some of the flight controls, just like the green hydraulic system also operates some of those flight controls. And then in this particular case with the thrust reverser, it's operating the number 2 engine thrust reverser. And of course you have a power transfer unit. Okay, so pretty much the same as your green hydraulic system. Okay, as far as operations and whatnot, you still have the high pressure and low pressure circuit, and you have those push buttons that are there, similarly, just that's labeled for the yellow hydraulic system. But as far as your valves, you're going to have the same valves. You also have your power transfer unit that's going to get pressurized again. that pressurizes that yellow high pressure circuit. Okay, so that's what's happening there. The PTU, just kind of touch on that. The PTU gets its power from the green hydraulic system. Okay, and that's supplying power to the yellow hydraulic system in case that the pressure in that system is falling again to what's the magic PSI. It's going to be 500 PSI, okay, below the pressure in the green hydraulic system. Because we're comparing the two systems when we're talking about that 500 PSI, we're talking about 500 PSI, below the pressure of the other system. Okay, all right, so, and of course, if we have an EDP fail, okay, it is, again, we have that happen, we're going to kick in the yellow hydraulic system with the electric pump. Okay, so that pump itself is connected to the HP supply downstream of a check valve. That check valve, of course, is installed in the output line from the electric pump to stop reverse flow of that fluid to the pump. Okay, of course, you can have ground supply, just the same as what we talked about earlier. And of course, just like we have on the green system, as far as having a way or system to, to check for the measurement of leakages, because we want to make sure there's not a leakage of hydraulic fluid. You have the same thing here with the LMS manifolds on that. Okay, so it's just the same as we talked about on the green hydraulic system. And again, just giving you kind of a visual view. The diagram again shows what the user systems are, and kind of shows at the bottom, if you look at that diagram, the reservoir filling, again, very similar to what we have in the green system. All right, and again, I don't want to repeat, there's some of the stuff, I mean, it's basically the same. There is, on the system accumulator, that has direct hydraulic connections to the HP, and also the brake manifolds. Okay, and to the cargo door selector valve. So we have that introduced, and then we have as far as the LMS manifold, measuring the internal leakage of groups of users. This is going to be to flight controls in the left hand wing, flight controls in the right hand wing, and also flight controls in the tail section, just like similar to what we had in the green system. As far as the number of check valves, you've got 2 check valves on the PTU manifold. You also have a priority valve as well there. And as far as the you have a solenoid valve installed in the PTU manifold controls, or you have in the PTU manifold. And again, that's just controlling that flow of fluid to and from the PTU. Okay, and just like the other one, you're going to have that one switch that when you operate that, it's going to energize both the 2 solenoid valves. Okay, and again, just the picture will give you a better idea there, but it's basically a repeat. Okay, and you guys have been around long enough to know it's pretty basic there. Okay, all right, so we're going to go ahead and get into a little in the blue system and go into the 3 different auxiliary generation systems that we have there. Now the blue system. The blue hydraulic system is made up of 2 subsystems. You do have the high pressure circuit and the low pressure or your return circuit. And the HP circuit, it supplies that hydraulic pressure to different applications. That would be the left and right spoiler 3, and you can see it on the diagram, all the listings of what it supplies. The ailerons, left and right, your slat wing tip brake, and also the left and right flap wing tip brake, and your elevators and rudder. It also can supply hydraulic pressure or power to the constant speed motor generator. So that's another one, and that's only as it's necessary. Otherwise, it's supplying to the those user systems. And then, as far as where are you going to find the components for the blue hydraulic system? Those are located. I mentioned in a general overview, is going to be in the left belly fairing, and that's forward of that main landing gear compartment. The exception of a few components which are actually located aft of the main landing gear compartment, and that'll be the blue hydraulic system's reservoir and its low pressure filter along with that. You also want to know that what comprises the blue hydraulic system as far as its sources. It's going to be your electric pump, your RAT, and your ground supply connections. Okay, and of course you have monitoring just like we have with the other systems, so your ECAM is going to show any faults that are going on, so it's pretty standard on that. And then the electric pump, of course, is going to start automatically, and we're going to have at least one of the engines having been started in order for that electric pump to start, and it's just operating continuously until both the engines are stopped. Also, it's possible to pressurize the system with the electric pump when the engines are stopped. Okay, there's that, remember I mentioned about the 50 VU panel. That's mainly your service panel, and just with a push button switch on that 50 VU maintenance panel, you can actually stop the automatic function of that electric pump. Now the ram air turbine, your RAT, that also supplies the blue hydraulic system with the high pressure fluid. It operates automatically just like the electric pump, but it does it when there's a total AC failure. So that's when it kicks in, is when there's complete electrical failure. Then the RAT is going to be operating from the flight compartment. Also on the ground, it's possible to pressurize the system from a ground supply. Okay, and that's pretty standard as far as the, what I mentioned before about the self-sealing connections for the ground supply, etc. So that's the same as what I mentioned before. There's also a pulsation dampener, and this is just kind of to smooth out the output of the electric pump. Okay, and that's just installed downstream of the electric pump. And there's also a pressure switch and a check valve just to make sure there's not an overpressure going on. So we have that. And then also the supply to all of them goes through the HP manifold, because remember what's very important in the Airbus is the fact that the high usage of the manifolds in order to have that output to the user systems. So again, we're high pressure manifold, that's going to be controlling the flow of fluid, okay, to your leak measurement selector manifold as well. So that's what is there. The valves, of course, the solenoid valve is operated from the maintenance manual. You've got your HP filters also installed, and you've also, just so you know, the filtration ratings, they're going to be at 15 micron, some of them are 25 microns. Just know obviously there's different filters, your high pressure, low pressure filters, depending on where they're located in the lines. All right, and the diagram just again gives you that visual just to remind you on the user systems coming from the blue hydraulic system. Okay, and then we also have a filter that's installed in the case drain line of the electric pump, and that's part of, that goes to the LP circuit. Okay, that's part of that low pressure circuit. And then the system reservoir is installed in the left hand belly fairing that's aft of the main landing gear compartment together with that LP filter. So that's where that's located. And of course that's holding the fluid. And it also makes allowance for any differences in the quantity of fluid, because of just different, different things that are going on. Like if you're changing the positions of jacks, etc. That's things like that. So you have the reservoir that's filled through the reservoir filling system, and we'll get into a whole chapter or session on that towards the end, on just the steps on filling the reservoir. This here you can operate from the ground service panel of the green hydraulic system, and of course you have a drain valve along with that.
Now, part of the description on the hydraulic systems is also the manifolds. There are high pressure and low pressure manifolds, and these are designed mostly to have most of the components installed on them. And also the way they're configured as far as the connections and the ports is to be able to accommodate the different dimensions of components. So let's go ahead and just take a look at the high pressure manifolds and see what kinds of components we have on that, and then we'll kind of move into low pressure manifolds. But just to give you an overview, your high pressure manifolds are obviously going to be, with the components that are responsible for the actuation of the hydraulic fluid to the user systems. And we're talking about the low pressure manifold, on the other hand. We're talking about return. So basically these are the connection points for the return lines that are going back to the reservoir. And also the low pressure manifold is going to play a part in the reservoir filling, which we'll get into in a later session. All right, so as far as the manifold, the high pressure manifold, you've got different connecting, or should say inlets and outlets. You've got 2 outlets to the LMS manifold, okay, for your leak measurement, and then you have 2 for the going to and from the PTO manifold, so 1 outlet and 1 inlet. And then you also have a connection to and from the system accumulator. And then as far as what's on here, you have solenoid valves, pressure relief valves, check valves, your sampling valve, of course your HP filters, the hydraulic pressure transmitter. You also have pressure switches for the flight controls, your system pressure switch, and you also have a priority valve. So I'll just mention a few things here, just kind of describing some of the valves. I'm sure you're familiar with a lot of them. I'm not going to go into great detail, but one thing that's important to note is the obviously we're going to talk about the where those thresholds are as far as your predetermined values, for example, in a pressure relief valve. So let's just going to go over that a little bit. Then we'll go into the components on the low pressure on that. So on the high pressure manifold, when we're talking about the solenoid valves, we do have one in particular. It's related to the operation of the cargo doors. Okay, this particular solenoid valve is called, you also see it as a yellow system solenoid valve, but what this does, it just basically keeps the flight controls from moving when the cargo doors are activated, either to open or close. So that's what that does. Okay, and then you also have, of course, a pressure relief valve. That pressure relief valve is a predetermined value at 235 bar. So, and if you guys are familiar with the Boeing 737s, anything, low, as far as manufactured here in the United States, we're going to be talking about PSI. If I refer to bar, that is a unit of measure, and I will mention to you what the equivalent is in PSI. So, I'll try to do that as I go along, but I just wanted to get you used to that a little bit if you're not used to seeing bars as a unit of measure. Airbus is a French manufacturer. Obviously, they have plants throughout the whole world, but just want to get raise that awareness with you. Okay, so on pressure relief valve, there is a predetermined value. Basically, pressure relief. If the pressure gets to be too high, and what's considered too high. Okay, too high is going to be at 237 bar, or the equivalent is going to be 3,436 psi. Okay, and that's when it'll open. And then when the pressure starts to go down, and gets lower and lower, what point is it going to close? Well, that point is at 220 bars, and that's at 3,190 psi. All right. Okay, so then you also have, of course, you've got HP filters. Your filters, just so you know, in the high pressure manifold, they're different from the low pressure filters. So don't think you can interchange them, because you cannot. They're also rated differently. So your high pressure manifold has, a filtration system at the system pressure inlet, and that rating is at 15 microns. Whereas on the low pressure manifold, we have LP filters there. Those are at 3 microns. So just so those are, again, the ratings for being able to capture, right, those particulates before it goes back into the reservoir. And I'm talking about on the low pressure manifold, okay, because that's what that does. Okay, so you have the check valves, pressure relief valves, your filters. You also have a sampling valve, and to just give you a better orientation of the different components that I'm mentioning here, you can go to the diagram. You can see the diagram, as I'm talking here. You can see, kind of give you how they're connected together. Okay, and if you get a look at this, you'll see, for example, the HP filter is connected there, and you also have a hydraulic pressure transmitter. And because you have to have these measurements for pressure. Obviously, we're going to be talking about monitoring and indicating and all that in another session. But here you've got pressure switches, and it's also where you have your relief valve, your sampling valve. Okay, so you can, again, I'm just kind of going in a clockwise position on the diagram when you're looking at that. You've got your hydraulic pressure transmitter, kind of at the, like say 7 o'clock. And then you have your system pressure switch kind of at 9 o'clock, and then about 10 o'clock you have your pressure switch. Okay, and then that's again for flight control, and then your solenoid valve at the 12 o'clock position on that diagram. And you can see kind of too that you can see the different isometric views on the yellow system, blue system, and green system, and kind of a blowing out of it where it's showing where it would be under the, obviously in the hydraulic compartment under the in the belly fairing of the airplane. Okay, so that gives you some idea there. And a filter's a filter. I mean, well, I shouldn't say there's lots of different kinds of filters. But basic components, you're going to have your filter head, your filter bowl, and filter element. Remember I said how there's a difference between your HP and your LP filters. They have different size heads. So that's why I say, can you interchange them? No, you cannot. Okay, so kind of keep these things in mind, because some of these things are going to be on the test. So not really big stuff here, but just something to be aware of, and I'll make sure you know what, kind of be aware of some of the questions that could come up. All right, so your pressure relief valve is a two-stage valve. You've got a primary and you've got a poppet valve. And as far as the way that works. And again, like I mentioned before about those opening and closing thresholds, 237 bar or 3,436 psi is when it opens, when that pressure gets to be a little too high. And then, of course, when it's coming down and that pressure is dropping, if it gets to 220 bars, okay, or 3,190 psi, that's when it's going to start closing. Okay, but just to give you kind of a orientation with the relief valve, it's a cylindrical body with a mounting flange. Okay, and again, there's so many different kinds, but that's what that's describing for this one. You also have a clogging indicator. This is part of the high pressure filter, because obviously, and there's also a bypass, because it's, for some reason it gets clogged. You guys are familiar with bypass valves. It's actually just going to head on over to the reservoir, from the return lines. So it's not going to, it's not going to stop it from going back in. It's just going to continue. But there's a clogging indicator that's a red pin that comes out, that kind of pops out, and that shows you that it's, that the element in there is filthy. So it means it's time to change it out. The indicator operates when the pressure differential, so there's a differential pressure that needs to go across that filter, and that magical number, okay, give or take about 8 psi, but that's 87. So, that's 6, plus or minus 0.6 bar, or 87 plus or minus 8.7 psi. Okay, so when that hits, that differential comes to that number, then that indicator is going to pop. It's going to be, it's going to pop. And once you clean out the filter, or not clean, once you replace that element and you get that back into functioning order, then you can actually push the put that red pin back in, and then the indicator is going to reset itself. Okay, it does it magnetic. There's a latch that's magnetic, and that's how it resets that thing. So also, it doesn't operate, and I'm talking about the clogging indicator, it's not going to operate if the temperature of the fluid is lower than a certain amount, and that is going to be below freezing. So 0 degrees Celsius or 32 degrees Fahrenheit, it's not going to operate. You also have, which is typical of filters, you get the anti-spill device on the filter head, so it's pretty standard. And again, remember I said before about the bypass device, you also have that. So it's for whatever reason it's clogged, it's still going to allow that fluid to get back into the reservoir. All right, and so check valves, just to give you an orientation on the kind that it is. There's a couple of ones that are used in this hydraulic system for the A320 and family, and that would be your cartridge type and also an inline type. All right, and so you're going to have the cartridge type installed in the HP. Okay, we're talking about the high pressure manifold right now, but it also, you're going to find this in the PTU manifold. Okay, so those are the two places that you have that kind of check valve. It's a stainless steel body with a screw head. You've got one end of the body that's closed, and then you've got a hexagonal head. The other end of it is open and is the fluid inlet. Okay, and there's outlets there's outlets on the sides of the body. Okay, and kind of gives you a better idea of that with the diagram. Again, is just kind of a basic diagram of orientation. All right, so then again, the check valves, if you look at the second kind, because that was the cartridge type, but then there's the inline, and the inline check valve is used on other installation positions. It's the same, has same cylindrical body. It's stainless steel as well. It also could be aluminum alloy, so either type of material. But what it's doing is holds the spring and the poppet in there. So that's that kind of check valve that you have there. And then the body has the hydraulic connections at the two ends. They are of different dimensions, okay, to stop the reversed installation of the valve, so you're not putting it in the wrong way. And then the internal seal of the valve, when it is closed, comes from metal-to-metal contact between the poppet and the valve seat. Okay. You also have a sampling valve, and that is actually part of that assembly, if you will, but that's also installed on the HP manifold. And it's just a cylindrical body, holds the needle valve, and it also has an end cap that has to be removed in order to get that sample, because it's sampling the hydraulic fluid, right? Okay, so there's that. And then you also have a hydraulic pressure transmitter. And I was kind of going clockwise, explaining the different components, and one of those is on kind of at the 7 o'clock position on the diagram is the hydraulic pressure transmitter. Okay, and there's 3 on the HP manifolds. There's 2 main sections to the transmitters. You've got one of them. Okay, one of them is a pressure sensing one, and then the other one has 2 circuit boards that are controlling the input voltage, and it's increasing that strength of the output signal from the switching element. So that's the job of the second section. The first one, again, is just there's a pressure sensing element there. That pressure sensing element, if you're not familiar with the different kinds, this one has a diaphragm, which is under hydraulic pressure, and that's just kind of the mechanism that it is, okay, on this transmitter, as far as that part of it. And then again, like I said, the second part is the actual circuit boards being able to control the input voltage. Now, as far as the type of voltage, I mean, it's pretty, standard across. We have an input voltage of 28 volt DC. But in this instance, you have the transmitter that can operate between 18 and 32 volt DC. Okay, so there's a range that it can still operate, or operate okay. The output voltage, that varies, and that ranges from 1 volt DC, okay, to 5 volt DC. Okay. You also have system pressure switches. There's type 2 switch assemblies that are made of two sections. You got your hydraulic and electrical, right? And you got your hydraulic operated piston, which moves the diaphragm. Again, pretty basic as far as when you have the diaphragm in there, and kind of the mechanical way that it does that with the hydraulics there. Then the movement of the diaphragm is transferred to the piston. Okay, so now we have transfer of energy to the piston, which moves the pressure plate. And then that's going to touch that disc spring, which is connected to the actuator, that goes to the switching element. So there's the chain of events, of how that's going. Switching element itself is kind of like a little micro switch on there, and it's a kind of, the way it's made is to kind of have like a click of the disc. Spring operates that switching element. Okay, so kind of give you a description of the system pressure switches. Okay, hydraulic part and electrical part, and everything I just mentioned right now. Okay, so again, gives you an idea on the components on the high pressure manifolds, and kind of just take notes because the knowledge checks are going to be specific. The knowledge checks, or test questions essentially, are going to go into a little bit of detail the way I'm explaining and describing some of the switches or valves. Okay, so what about the low pressure manifolds? They're made of the same material, okay, as the HPs. As far as your components, on the low pressure manifold, you've got filters, okay, you got LP filter. You also have temperature transmitters. There's 3 of them, and the 3 they're all the same, okay. They're not of different dimensions. You actually can interchange them, and so again, follow procedure, per AMM, but just letting you know there's 3 temperature transmitters and they're all the same. They can be interchangeable. They also have sensors. Of course, the transmitters have to have sensors, and there's 3 of them in one unit. Okay, and there's an electrical connector and a bonding stud that's attached to the body of the actual transmitter. And as far as the sensors that are part of that, there's 2 kinds. You have you got the temperature transducers, and you also have a temperature switch that's actually sending a discrete signal, okay, and that's kind of a terminology in the electrical world here, but at any rate, it sends that discrete signal to the overhead panel and the ECAM, okay, to the flight compartment. The other one I was telling you about, the transducers, is they're providing the analog signals. So you've got discrete signals to the overhead panel and ECAM, and then you also have those transducers, which are providing the analog signals to the 2 ECAM displays. So when we're talking about the temperature switch, that is set to operate, at a certain, temperature set at 95. Let's just kind of do degrees Fahrenheit. At 203 degrees plus or minus about 4 degrees Fahrenheit, or if you want to look at it from a Celsius standpoint, at 95 plus or minus about 2 degrees Celsius. Okay, and to reset, it's set to operate there, and it's set to reset if the fluid temperature goes below 88.4 degrees Celsius, or 191 degrees Fahrenheit. Your temperature transducers, okay, what do they do? Okay, they're measuring the fluid temperatures. Okay, and there's a range also here between negative 55 degrees Celsius, okay, and 120 degrees Celsius. Okay, that's at 248 degrees Fahrenheit. Okay, so just giving you kind of an awareness of those ranges, those preset as far as what they're designed to operate within. And the transducers, just to give you a little extra information on this one, that range is there in kind of keeping a way to, basically kind of keeping accuracy of reading what that temperature actually is, and being able to have that on the ECAM display so the pilots can, have a better idea. And it's just, again, it's creating that better accuracy with all of that. Okay, so again, these are, and the diagram gives you an idea, kind of orientation of, with the relationship between your LP filter, your clogging indicator, where it's that located on the filter head, and then you see the temperature transmitter on the diagram. So again, I'm going from the bottom, so kind of, and then going clockwise with that description I just said. And again, the diagrams are just giving you that orientation. Okay. So again, high pressure manifolds, low pressure manifolds, and we're going to go ahead and move along with some of the information on ground service panels. All right, we're going to go ahead and go over some knowledge checks. These are questions that you may see on the test, and these are going to be knowledge checks for sessions 1 through 3.
Okay, remember session 1 was the overview, session 2 was hydraulic controls and ECAM indications, and session 3 was descriptions of the green, yellow, and blue systems. All right, so let's start with question number 1. What are the colors of the main engine-driven hydraulic systems? Okay, is it green and yellow or green and blue? Okay, it's green and yellow, right? All right, question number 2. Name 3 user systems that are supplied by the 3 hydraulic systems. Here are the 2 choices. Choice number 1, the landing gear, air conditioning, and flight controls, or the landing gear, brakes, and thrust reversers. Okay, it's the latter. All right, number 3, to reduce potential damage to or movement of the pipes, the manifolds are primarily used in the systems. Is that true or false? Okay, it's true. Pressure relief valves of the reservoirs are connected to the sealed drain system. Is that true or false? That's a true statement. Okay, number 5, the yellow hydraulic system components are located in which belly fairing? The right belly fairing or the left belly fairing? Okay, it's the right belly fairing. The ground service panel is available for only the blue system. Is that true or false? Okay, it's false. It's available for all 3 systems. All right, question number 7. The ground service panel of the green system has a hand pump, a filter, and a selector valve so that any of the reservoirs can be filled from it. Is that true or false? Okay, that's true. Question number 8. The ground service panel of the yellow system has a hand pump and a selector valve. They give an alternate method to operate what? Okay, your 2 choices are the cargo doors or air conditioning. Okay, it's the cargo doors. Okay, the ground service panel for which system has the ram air turbine control panel? Is it the yellow or the blue system? Okay, remember that's the blue system. Okay, question 10. Reservoir volume of the fluid for the green system is approximately 100 liters or 60 liters. Okay, it's 100 liters. Question 11. If the yellow hydraulic system's pressure decreases to 500 psi less than the green hydraulic system's pressure, what automatically operates? Is it the flap motor or the PTU? Okay, it's going to be the PTU. Okay, question 12. At what pressure does the pressure relief valve open? Okay, is it at 3020 psi or 3436 psi? All right, it's the latter. Okay, 3436 psi. Question 13. At what pressure does the pressure relief valve close? Okay, does it close at 3190 psi or at 3000 psi? Okay, that's going to be at 3190 psi. Question 14. If the pressure is too low, the priority valve stops the supply of fluid to non-essential users when the pressure decreases to what pressure? Okay, at 1885 psi or 1020 psi? Okay, the answer for that is the first one, the 1885 psi. All right, question 15. Regarding the HP manifolds, how many transmitters are installed on it? Is it 2 or 3? Okay, it's 3. Okay, question 16. Regarding the fire valve indication, a green circle with a vertical line indicates what? Okay, here are your 2 choices. Valve is fully closed or valve is not fully closed. Okay, which is it? Okay, the green circle with a vertical line indicates the valve is not fully closed. That's the answer. Okay, question 17. Regarding the fire valve indication, an amber circle with a horizontal circle indicates Okay, valve is fully closed or valve is not fully closed. Okay, it's going to be the other choice, right? Valve is fully closed. Question 18. If the hydraulic fluid temperature goes above normal, then the reservoir overheat indication appears in amber along with what other message? Is it the EWD caution message, or there's no other message that appears? Okay, it's the first one. Okay, you are going to see a caution message on the EWD. Okay, question number 19. There are two memo messages that that will display on the right side of the EWD page. What are they? Okay, your two choices. The first one is rat out and reservoir overheat, or hide PTU and rat out. Okay, it's the latter. Hide PTU and rat out. Those are the two memo messages. Question number 20. The green hydraulic system has two subsystems. What are they called? Okay, your first choice is HP circuit and LP circuit, or normal and alternate. Okay, we covered that. It's your HP and your LP circuits. Question number 21. From where does the PTU get its power? Okay, the yellow or the blue system? Okay, it's going to be yellow. Okay, and that's if something's wrong, we have some kind of problem with the green system. Question number 22. The PTU can pressurize which subsystem of the green system? Okay, the HP circuit or the LP circuit? Okay, it's going to be the former. It's going to be HP circuit, right? Because it's trying to make up for that lack of pressure, so it can get over to the main user systems. Question 23. There's a hydraulic connection between the green and yellow systems. Is that a true or false statement? Okay, that's false. There is no mixture, so you don't have a mixture of the we're talking about hydraulic fluids, so they're isolated. Question 24. Two push button switches operate two solenoid valves to stop the flow to and from the PTU manifold. Is that a true or false statement? Do you recall? Okay, that's a false statement, because remember I said there's only one push button switch. When you operate that switch, both those solenoid valves are gonna energize. Okay, question number 25. To which two user systems does the blue hydraulic system supply power? Okay, your first choice. Left-hand slat power control unit motor and the CSMG, or the right-hand slat power control unit motor and the cargo doors? Okay, it's the first choice. Okay, on the blue system, it's supplying power to the slat PCU motor and also the CSMG. Question number 26, our last one for this part anyway, is the HP manifold has how many outlet ports to the LMS manifold? Okay, your leak management. Is it 2 or 3? Okay, it has 2. That's the answer. 2 outlet ports to the LMS manifold. All right, so that gives you an idea with, and a good idea actually, with some of the questions that you may see on the test. This does help you quite a bit. Still go over the information, but these handouts are your, it's kind of your gold, if you will. So just review those and play back the video if you need to. But that concludes the knowledge checks, our kind of a review, if you will, of sections 1 through 3. We are now on to session 4. This is ground service panels. I'm not going to go into a whole lot of detail, just giving you an idea on where they're located and kind of what connectors we have here. We have the yellow and blue hydraulic systems from the ground supply. Okay, they can be pressurized by a ground supply, and the connectors are located on ground service panels. You have the yellow hydraulic systems ground service panel that's installed in the right belly fairing. Okay, that's after the main gear compartment, and then you have the blue one that's in the left hand belly fairing. Same thing, after the main landing gear component.
So you have the components and connections here that are necessary to service the system. Okay, and this doesn't include pressurization connection for the reservoir, just so you know. But all of this is grouped together kind of in a group. Okay, so the ground service panel has different components. You have your ground test suction and delivery connectors. Okay, that's 2006 GM and 2008 GM. You have a depressurization valve of the reservoir. You also have a drain valve of the reservoir and the rat control panel. And if you just look at the pictures, a couple of pictures here, but have a diagram that gives you an orientation of, you know, kind of in relationship to one another, what's on the panel. So you have your ground test section connection at kind of the 1 o'clock and going clockwise on the diagram. And then you have a cargo door L-man selector valve towards the bottom. You also have the cargo door hand pump. Okay, remember, hand pump's on the yellow system, so you have that located there. In the center, kind of more towards the center, and you have the yellow reservoir depressurization connection. And then at the top left, you have the ground test pressure connection. So you have that to plug in. So again, just giving the orientation with the different parts on the ground service panel. And there's also a photo. You can look at the photo and it shows you there, give you a better idea when you get to the airplane. Okay, so gonna get just about, if you have any questions, you know, definitely we can answer those questions for you. Okay, and there's the rat control panel. Just kind of, you look at the right half of the diagram, you'll see the rat control panel, rat control panel, kind of in the center. Okay, and then you got your depressurization valve on the left and right, your right on the suctions on the right. Okay, so again, really not much to that. Just know where it's located, where each of them are located. Okay, all right, we're going to go ahead and move on to the next session. All right, now we're on to talking about the hydraulic reservoir filling. You know, how do you fill the hydraulic reservoirs? And we're talking about all three of them. You're able to do it from one place, and that would be at the ground service panel of the green system. So from here, you're able to, through a selector valve, be able to supply and fill each of the hydraulic reservoirs. So here at the green system, we're talking about the ground service panel of the green system. That's where you're going to find the components for filling. The things that you won't find are the 3 check valves, which are installed on the actual supply lines to the reservoirs. Also, the system can use a container or the ground hydraulic supply as a source of hydraulic fluid. If you use the container, then there's a flexible pipe that makes the connection between the container and the hand pump. Okay, and you must connect it to the fill valve, which is installed in the suction port of the hand pump. Okay, and that includes a filter and a check valve. There's also a coupling socket, and that's the connection for the pressurized ground hydraulic supply. There's also a restrictor that's between the coupling socket and the selector valve. So I want to talk a little bit about the coupling socket, and then I'll go into a little bit on the fill valve, and then go into the selector valve. So with the coupling socket, this is the connection for the pressurized ground supply of the fluid, and that's installed on the ground service panel of the green hydraulic system. And with this, you can fill the hydraulic reservoirs. So with the socket, it's one half of a self-sealing quick disconnect coupling, and the other is attached to the ground hydraulic supply. Also, you have a blanking cap, which is attached to the body of the coupling with the cable. Now, the fill valve, is the connection for the flexible hose that fills the reservoirs with the hand pump. Okay, and that's with an unpressurized container. The fill valve itself is installed on the suction connection of the hand pump. There's a valve assembly, which includes the check valve. All right, so and there's the diagram giving you, again, the kind of relationship between, you know, all these different components. You do have your filters, your coupling socket. You can see it on the right side of that diagram. At the bottom, you got the flexible hose, the fill valve, and the hand pump. Okay. All right, and of course you got the filters. You're going to have that there. But I wanted to talk a little bit on the selector valve, because what it does is enabling to obviously select which hydraulic reservoir that you want to fill. So with here, it directs that hydraulic fluid there. There's 4 positions for it. You've got 3, one for each of the hydraulic systems, your yellow, blue, and green. And then there's another position which is it has a label on neutral, which is an off position. Okay, and it's a spring detent mechanism that keeps the selector valve in its set position. So you've got those 4 positions. So just test question here. Okay, selector valve has how many positions? It has 4. The selector is a 4-port 4-way valve. Okay, it's turned by a shaft that's connected to the operating handle. That handle is also a pointer to show which system is selected. Okay, and just so you know, the angle as far as the positions, those set positions are 90 degrees of each other. And I'm just going to reiterate. I mean, there's a picture there again. Okay, you see of the ground service panel. Okay. All right. Now, the ports on the selector valve, they're labeled, and they're labeled B, G, Y. Okay, that's for the blue, green, yellow, and then you have the A, which is for your supply inlet. Okay, so those are your identifiers for the 4 hydraulic ports on the selector valve. There's a thermal relief valve that protects, obviously from thermal expansion of the fluid when it's in the neutral position. So you may want to keep that in mind. That's probably going to be a test question. Is what position is the selector valve in when the thermal we're worried about or concerned about thermal expansion? Okay, and that's going to be the neutral position. Now, if there's an expansion of fluid, we're going to have the pressure go up. So when that goes to the thermal relief valve, will open at 50, okay, or excuse me, 507 plus or minus 72 psi, okay, or 35 plus or minus 5 bar, and it'll close when that pressure, when that drops down to, or temperature drops, or pressure, drops down to 290 psi. Then it's going to close. The fluid is then, going through the relief valve out of the port, and that's connected to the yellow hydraulic system. There's also an electrical switch unit that's attached to the selector at the bottom, and that, the same shaft that I was mentioning a bit ago operates this hydraulic selector that operates the switch unit. So it's kind of, that's the connection there. There's a ratio, it's a reduction gear of 3:1 that reduces the travel of that switch in relation to the input shaft. Okay, that assembly is made up of a double wafer and a double rotor, and together they're creating, making the switch where you're able to have, being able to select neutral, the N, the Y, the B, the G. There's also seals that are installed between the hydraulic and the electrical parts of the selector valve assembly, and that's just to make sure that, obviously there's no fluid that goes into the electrical switch mechanism, but it just goes out, somewhere else. Okay, so you also have there's the reservoir depressurization valve, which is, I mentioned earlier, it's a two-way valve. It is manually operated, and it's installed in the ground service panel of the related system. Okay, it's connected to the applicable reservoir with the pipes, and so you can depressurize that particular reservoir, without having to depressurize anything else. All right, so and of course, you do have the indicator, of course, to see, when you're filling it, where it's going to be, because you want to make sure it's filled within the right amount. And again, that indicator is on the ground service panel of the green system, because that's where you can supply that hydraulic fluid to all 3 reservoirs. Okay. If you operate with the hand pump, one end of the flexible hose is put into the fluid container, and the other one is connected to the fill valve. Okay. And underneath the hand pump, that fluid is drawn through the pipe to the fill valve. Okay, it goes through the filter and the check valve of the fill valve and into the hand pump. And of course the pump is there to pump the fluid. So it goes through that high pressure filter to the selector valve. Okay, kind of the chain of events there, what's happening. Okay, and there's, again, just the picture for reference. Okay, now if you're going to operate it with the ground hydraulic supply, then you're going to have that supply connected to the self-sealing coupling, and the fluid under pressure is going to flow into the filling system. You have a restrictor there, which is decreasing the pressure of the fluid before it goes through the HP filter to the selector valve. Okay, so kind of a basic process there. All right, we are on to session 6, which is seal drain system. And this here, what's the purpose of the seal drain system? This is going to be collecting any hydraulic fluid from the seal drains of certain components of the different systems. Okay, and the air relief valves are also connected. We're talking about air relief valves of the reservoirs are also connected to the seal drain system. And this is to collect any fluid which is coming out of the reservoir if the pressure in that reservoir turns out to be too high. So that's what that seal drain system is for. It also is going to give some protections. Obviously, if the reservoirs are overfilled and there's an excess flow of fluid that's necessary to come out, then it's going to be able to do that. There's also a collector tank. If that is full, then that fluid comes out of that overflow pipe. Okay. So the fluid from a given component, goes through the system of pipes, and it's going to go to one of two collector tanks. There's two collector tanks. There's the forward collector tank and the aft collector tank. And these are located in the main hydraulic compartment. It's attached to the right. Actually, the aft collector tank is attached to the right side of the keel beam. Okay, that's forward of the FR46. The forward collector tank is in the yellow hydraulic compartment. Okay, and that's attached between FR40 and FR41. The seal drain system, when you're looking at the two collector tanks and their capacities, they each can hold about 0.1981 US gallons, or 3/4 of a liter. So that's what they're there for, is collecting that excess. They are attached to the structure with some clamps. Okay, so it can be easier to drain. The components that you have which drain into the forward, compared to the aft. So we're going to look at what components drain fluid into the forward collector tank versus the aft collector tank. And that would be in the forward collector tank. As far as what gets drained into that is going to be anything coming from the electric pumps of your blue and yellow systems, your PCU, and also your air relief valves from the green and yellow, your major reservoirs. And then as far as into the aft collector tank, that would be any remaining from your CMG, your constant speed motor generator, and also of course the air relief valve from the blue system reservoir, your PTU and PCU. Okay. Just so you know about the material, the hoses are made out of silicone, the pipes are made out of aluminum, and they are designed so that the fluid drains into those tanks under the influence of gravity. It's gravity driven. And you can see the diagram to give you an idea of what's happening. Okay, it shows you in the top part your yellow electric pump. Okay, and you've got your green system reservoir and your overflow pipe as well. Okay, and your blue electric compartment. So I said that in the forward collector tank, it's going to be coming from your yellow and your blue electric pump. So you see that there on the diagram. Okay, and then at the bottom you can see for the other tank, where it's coming from. Okay, and the different areas is coming from your, example, your constant speed motor generator. And it shows that on the diagram. Okay. Okay, so that just gives you an idea of the seal drain system. Again, just its purpose is to just get rid of excess fluid. We are now on to session 7, the engine-driven pumps. The engine-driven pumps are located on the accessory gearbox on the bottom of the engines, and there's also a case drain filter that's located on the left side of that engine, just above the EDPs, and that's to obviously filter the fluid that's coming from the pumps. So with the EDPs, there's two kinds of pumps. You have a Vickers pump and an ABEX pump. They each have 9 pistons, and the operation's the same for both of them. It's just a little bit of difference in the components. So when you're looking at the Vickers pump, this is a variable displacement type, which is pretty typical for this kind of operation anyway. And then you have what's here is a yoke plate. When you're looking at the ABEX pump, it's called a hanger. So it's a different component, but it's going to be operated upon similarly, in order to have a certain result. So with the Vickers pump, there's a yoke plate, and that is a movable plate. So what happens is when that angle changes, of that plate, then that's going to change the strokes of the pistons. Okay, it's going to change that distance, and of course that's going to affect the output of the pump, whether increasing or decreasing if it's short or a longer stroke. Now what kicks off the angle, what changes that angle of the yoke plate? Well, that's going to be a compensator valve that's supplying that servo pressure to the actuator piston, which controls that angle. So that's what that's coming from. On the ABEX side, okay, on the ABEX pump, it operates similarly, but it doesn't have a yoke plate. Instead, it's what they call a hanger. Okay, and that is, we're talking about the angle of the hanger. So when the angle of the hanger changes, then it's going to affect the stroke of the pistons. That's going to change, short strokes, long strokes, and of course that's going to affect the output again of the pump. So very similar. They both have the solenoid valve. Okay, that's going to change that operation of the pump in supplying the pressure. And so when you're looking at the solenoid valve, we're talking about the Vickers pump. There's a blocking valve, and what that's doing is isolating that pump from the hydraulic system. Okay, and that's having to do when the pump operates in the depressurized mode. On the ABEX side, similarly, you have the valve. This is going to get energized. It's going to affect the blocking valve so that it stops that output from the pump. Now, just a reminder, operating pressure, okay, from EDP with zero flow is 3,000 psi. Okay, that's typical across aircraft. Hydraulic systems is supplying that 3,000 psi. And so those do the same thing. That drops a little bit to 2,800 or so when there's an actual flow. Okay. Also, just another feature with the pumps is you have two things related here. Obviously, we're dealing with pressure, so either something has too much pressure or it's getting too low. So what's happening? What do we have here to kind of keep things in balance with the pressure of the EDPs? Well, we have the case pressure relief valve. That's one, because when the pressure gets too high, we want to make sure we have a relief of some of that pressure. Number two, you have an inlet boost impeller, and that's there in case the pressure is not enough. It dropped below too low, and now it has to be boosted essentially up to the pressure so that it can maintain a balance. So that's what that inlet boost impeller does. Increases that pressure of the fluid at the inlet of the pump. And again, that's just making sure that in any condition of the operation of the pump, that it's getting a supply of fluid, pretty regularly, consistently. And if you look at the diagram, you see that it gives you you can see the difference in configuration between the ABEX pump and the Vickers pump. Okay, this kind of giving you a blowout of where it's located because it's on the left hand side of the engines. But you can see how they're different. Of course, you got your ports, but just the way it's configured is what I wanted to point out to you. Okay, you can see your seal drain connections there. You've got the inlet and outlet ports. Okay, you got your K-strain port showing on the ABEX pump. And of course you have your solenoid valves on each of those. But I just wanted to get a visual on that. K-strain filter, while we're on this picture, just simple basics: filter head, clogging indicator, and filter bowl, just like we've talked about up until this point. So nothing new there. All right, but I definitely wanted to get an orientation of the of those two pumps. Okay, all right, so we have those, and then when we're talking about fluid, because we're going to have, obviously you've got drain fluid that's going through a pipe. That fluid is going to drain into a collector tank. I know I mentioned earlier about a forward and aft collector tank. Here this is going into a collector tank, which holds that fluid, and that fluid is going to be kept apart from the drain fluids from other components. Okay, so in particular we're talking about the draining of hydraulic fluid from the engine-driven pump cases. Okay, and this also, the tank itself, you can manually drain it, so you can actually empty it out manually. You also can measure the amount of leakage from the EDP, so that's important, and you're able to do that and measure that. And then, so of course, anything that's is an excess fluid, that's just going to go overboard through the power plant drain system. Okay. Now, when do we not want to have hydraulic fluid to the ADP? Okay, which goes everything else, right? When do we not want to have that? Okay, well, we don't want to have that. We have a fire in the nacelle, right? So that's going to be a problem. I'm going to talk a little bit about the fire valves, because at this point, when we talk about the supply of fluid to the EDP, we want to, if the flight crew wants to stop it, they can close a fire valve, and that'll just shut off that supply. The thing is, it can't be shut off for too long, or it'll ruin the EDP. But that's just, this is an emergency. There's a fire in the nacelle. So let me just kind of switch over on the side here for you, just in your mind, and go over a little bit on fire valves. These are the engine pump fire valves, and then we'll continue on with engine-driven pumps. But I wanted to address that since they are, there's an association here. So the fire valves, this is enabling, again, this is engines. What's the threat to engines? It's fire. That's a big threat right there. So we want to make sure we don't have anything to continue that potential hazard, fire hazard. So the fire valves, these are push buttons in the flight compartment for engine 1 fire, engine 2 fire, push buttons. So flight crew can actually close those fire valves. You also have a compensation slide that takes temperature changes, or any kind of movement of the wing, which changes the length of the pipework, and that compensates it in the unit with the movement of the piston. So you have that compensation valve. And if you look at the diagram, you can look at it while I'm talking, but it's, you can see the compensated slide at the bottom of the page on that diagram. Okay. And of course you can look at the fire valve itself, is showing that, and how the compensated slide is fitted there through a threaded connector. Okay, so the fire valves installed, just where it's located, they're installed in the left hand and right hand wings between the rear spar and the rear fault spar, and that's inboard of the pylon. It's in the suction line between the reservoir and the engine-driven pumps. There's 2 parts to the fire valve, okay, and you see the diagram there just to give you orientation. But you've got a valve and an actuator assembly. Okay, those are your 2 parts. Your valve assembly has an inlet and an outlet, okay, with the ball valve between them. And the 2 connections aren't the same. That way you don't have a chance of putting it the wrong way or anything like that. It is deliberately 2 different sizes on the ends. So it only goes one way, is what I'm trying to say. There's also an arrow which shows the direction of the flow through the valve, okay, and that's located on the body of the valve assembly. Also, the ball turns 90 degrees each time it operates, so it's at 90-degree turns. Now, what about the actuator assembly? Okay, this has a housing, and this one holds an electric motor. You've got your gearbox and limit switches. You've got the in the gearbox you have a worm gear and a norm gear. Okay, And then you have the spur gears. The spur gears are actually connected to the worm gear that connects to the motor, and it connects to the output shaft as well. I'm talking about the worm wheel. The worm wheel, okay? The worm wheel is connected to the output shaft, okay? There's also the coupling that connects the output shaft to the gearbox with the valve assembly. And you also have a valve position indicator for the output shaft. There's an indicator that's located on the top of the actuator assembly. And what's on there? You know, what positions do we have? Well, what you're going to see on there is open or shut. So those are your two choices of position on that valve. Okay. The shaft, like a lot of shafts, have cams. So you have a cam here with an actuating lever that operates some switches. Okay, we're talking about limit switches. Earlier, this, you know, what's what we're talking about here. The cam causes a switch to open. Okay, so we have kind of a, you know, kind of a two-position logic here. One switch to open, one to close it. And it's either going to be in the fully open or closed position. Okay, so there's just the two on this one. All right, but I was talking about the limit switches inside the gearbox is what you have there. Okay, so it kind of gives you an idea. Again, the picture, just kind of get yourself familiar with, you know, what it looks like. Okay, and then the gearbox are reduction gears, so that's the type that they are. And there's also the indicator on that box is attached to the gearbox output shaft. Okay, it's like has a window in the housing, so you can see the indicator shows red when the valve is open. Okay, and when it's closed, it's going to be green. So green indicator means it's closed. Red indicator means that the valve is open. Okay. All right, so you have that. And then just a little bit on the compensated slides. Okay, if you look at the picture, just so as I'm talking, you can look at it. There's 4 orifices that create ventilation. And that also has filters and your filter retainers. The scraper ring, you have that retained by a circlip that's installed in the housing. And you're familiar with scrapers probably, so if you know anything about scrapers, which I'm sure you do, we're just talking about being able to, you know, stop contamination. We don't want to have contaminants, you know, in there, so you have that scraper ring. Of course, you have O-rings that are installed in the housing. The O-rings the O-rings are sealing the different shaft diameters. Okay, so, and that's of the piston, so you have different sizes on that. Okay, so I'm just giving you an orientation, a little bit familiar with the fire valves, you know, as it relates to the engine pumps, because we don't want to have a continuation of flow of hydraulic fluid to the engine pumps if we have, you know, a fire hazard. Okay, so that's why we have that. Okay, so back to the engine driven pumps, you know, I talked about, you know, obviously the fire valves, but now the K-strain filters, they're similar as to the ones I mentioned earlier about HP filters, your high pressure filters. Again, they're different in size. So remember what I said, how you cannot interchange HP with LP filters. They're 2 different sizes. The configuration is different on the filter head. Same thing here with the K-strain filter, you know, and the HP filter. They're similar, but they have their differences in the sizes. Okay. Same thing as before. You've got your filter head, your clogging indicator, and of course anti-spill device in your filter bowl. This is the kind that you just, you know, you yank out and replace with a new filter element. Okay, this is not the kind that can be cleaned. You just simply replace, like I mentioned that before, it's just that kind. The rating for this filter is 15 microns, just so you know. All right, what about pressure switches? Okay, pressure switches, we have type 1 and type 2. There's the type 1 is going to send a low pressure signal at 1740. This is for the engine driven pumps. Okay, and then the other one, type 2 switch, is actually for sending, is for the electric pumps. Okay, so type 1 switch sends a low pressure signal at 1740 psi. Okay, give or take about 72 psi. That equivalent in bars is 120 plus or minus 5 bar. Okay, it sends that low pressure signal at 1740 psi pressure decreasing and stops that signal before the pressure is 22 psi. Okay, so if it drops, it's going to send the signal. If the pressure starts to increase and it, before it gets to 2200 psi or 152 bar, then the signal is going to stop. Now, what about type 2? Okay, your type 2 switch is sending a low pressure signal at 1450 psi. Okay, give or take same amount as the other one, about 72 psi, when the pressure is decreasing, right? And then sends a high pressure signal right before, as pressure is increasing, before it reaches 1750 psi. Okay, so remember about switches I mentioned before, has electrical and hydraulic connections, and those are of different dimensions on there. Okay, all right, and you also have a pump pressure monitoring and indicating. Okay, so we want to make sure we do monitor that. The pressure switches are there to do that. You also have the transmitters. So again, those transmitters are being able to, relay that information to the ECAM display, right? And show that to the flight compartment, to the flight crew in the flight compartment. So you have that. Your indicating system, you have, as far as where, you got system pressure that's monitored downstream of the EDP, and that's for your yellow and green systems. And then you have another one that's downstream of the electric pump of the blue system. Okay, and then we also have system pressure being monitored at the HP manifolds. That's your green, blue, and your yellow systems. And then also the brake manifold. And I'll talk about the brake manifold a little bit later, but that's another place where pressure is being monitored. Okay. Okay, so kind of giving you an idea on the critical thresholds with the pressure switches, for type 1 and type 2. And then just to remember, I mentioned before about the pressure falling below, I mentioned 1740 and below 1450. So I'm talking about the engine pumps for the blue, for the dropping at 1740 for the engine pumps, okay, the engine driven pumps, and then dropping below 1450 for the blue electric pump. Then when that happens, of course, in electricals, right, the contacts are going to close in order to send those signals to the SDAC and the ECAM. Okay, and the same signals show up on the display. Master caution warning lights are going to show, are going to light up, and then you got your pump low pressure warning that comes on the hide page that's on the ECAM, and same thing on the EWD of the ECAM. And then remember I mentioned that single chime audio warning. You're going to also have that in this case as well. Okay, so kind of giving you just an idea on the two different kinds of pumps. You got Vickers and ABACs, and how they're different in configuration, but their operation is the same. They may have slightly different components, but their objective is the same. They each have 9 pistons. Okay, so just kind of giving you a rundown on that. All right, that's on your engine-driven pumps. And our next session we're going to be covering is on electric pumps. All right, we're going to go ahead and go over some knowledge checks. These are questions that you may see on the test. And these are going to be knowledge checks for sessions 1 through 3. Okay, remember session 1 was the overview, session 2 was hydraulic controls and ECAM indications, and session 3 was descriptions of the green, yellow, and blue systems. All right, so let's start with question number 1. What are the colors of the main engine-driven hydraulic systems? Okay, is it green and yellow or green and blue? Okay, it's green and yellow, right? All right, question number 2. Name 3 user systems that are supplied by the 3 hydraulic systems. Here are the 2 choices. Choice number 1, the landing gear, air conditioning and flight controls, or the landing gear, brakes, and thrust reversers. Okay, it's the latter. All right, number 3, to reduce potential damage to or movement of the pipes, the manifolds are primarily used in the systems. Is that true or false? Okay, it's true. Pressure relief valves
of the reservoirs are connected to the sealed drain system. Is that true or false? That's a true statement. Okay, number 5, the yellow hydraulic system components are located in which belly fairing? The right belly fairing or the left belly fairing? Okay, it's the right belly fairing. The ground service panel is available for only the blue system. Is that true or false? Okay, it's false. It's available for all 3 systems. All right, question number 7. The ground service panel of the green system has a hand pump, a filter, and a selector valve so that any of the reservoirs can be filled from it. Is that true or false? Okay, that's true. Question number 8. The ground service panel of the yellow system has a hand pump and a selector valve. They give an alternate method to operate what? Okay, your 2 choices are the cargo doors or air conditioning. Okay, it's the cargo doors. Okay, the ground service panel for which system has the ram air turbine control panel? Is it the yellow or the blue system? Okay, remember that's the blue system. Okay, question 10. Reservoir volume of the fluid for the green system is approximately 100 liters or 60 liters. Okay, it's 100 liters. Question 11. If the yellow hydraulic system's pressure decreases to 500 psi less than the green hydraulic system's pressure, what automatically operates? Is it the flap motor or the PTU? Okay, it's going to be the PTU. Okay, question 12. At what pressure does the pressure relief valve open? Okay, is it at 3020 psi or 3436 psi? All right, it's the latter. Okay, 3436 psi. Question 13. At what pressure does the pressure relief valve close? Okay, does it close at 3190 psi or at 3000 psi? Okay, that's going to be at 3190 psi. Question 14. If the pressure is too low, the priority valve stops the supply of fluid to non-essential users when the pressure decreases to what pressure? Okay, at 1885 psi or 1020 psi? Okay, the answer for that is the first one, the 1885 psi. All right, question 15. Regarding the HP manifolds, how many transmitters are installed on it? Is it 2 or 3? Okay, it's 3. Okay, question 16. Regarding the fire valve indication, a green circle with a vertical line indicates what? Okay, here are your 2 choices. Valve is fully closed or valve is not fully closed. Okay, which is it? Okay, the green circle with a vertical line indicates the valve is not fully closed. That's the answer. Okay, question 17. Regarding the fire valve indication, an amber circle with a horizontal circle indicates, okay, valve is fully closed or valve is not fully closed. Okay, it's going to be the other choice, right? Valve is fully closed. Question 18. If the hydraulic fluid temperature goes above normal, then the reservoir overheat indication appears in amber along with what other message? Is it the EWD caution message or there's no other message that appears? Okay, it's the first one. Okay, you are going to see a caution message on the EWD. Okay, question number 19. There are 2 memo messages that that will display on the right side of the EWD page. What are they? Okay, your 2 choices. The first one is rat out and reservoir overheat, or hide PTU and rat out. Okay, it's the latter. Hide PTU and rat out. Those are the two memo messages. Question number 20. The green hydraulic system has two subsystems. What are they called? Okay, your first choice is HP circuit and LP circuit, or normal and alternate. Okay, we covered that. It's your HP and your LP circuits. Question number 21. From where does the PTU get its power? Okay, the yellow or the blue system? Okay, it's going to be yellow. Okay, and that's if something's wrong, we have some kind of problem with the green system. Question number 22, the PTU can pressurize which subsystem of the green system? Okay, the HP circuit or the LP circuit? Okay, it's going to be the former. It's going to be HP circuit, right? Because it's trying to make up for that lack of pressure, so it can get over to the main user systems. Question 23, there's a hydraulic connection between the green and yellow systems. Is that a true or false statement? Okay, that's false. There is no mixture, so you don't have a mixture of the, we're talking about hydraulic fluids, so they're isolated. Question 24, two push-button switches operate two solenoid valves to stop the flow to and from the PTU manifold. Is that a true or false statement? Do you recall? Okay, that's a false statement, because remember I said there's only one push-button switch. When you operate that switch, both those solenoid valves are gonna energize. Okay, question number 25. To which two user systems does the blue hydraulic system supply power? Okay, your first choice. Left-hand slat power control unit motor and the CSMG, or the right-hand slat power control unit motor and the cargo doors? Okay, it's the first choice. Okay, on the blue system, it's supplying power to the slat PCU motor and also the CSMG. Question number 26, our last one for this part anyway, is the HP manifold has how many outlet ports to the LMS manifold? Okay, your leak management. Is it 2 or 3? Okay, it has 2. That's the answer. 2 outlet ports to the LMS manifold. All right, so that gives you an idea and a good idea actually with some of the questions that you may see on the test. This does help you quite a bit. Still go over the information, but these handouts are it's kind of your gold, if you will. So just review those and play back the video if you need to. But that concludes the knowledge checks, or kind of a review, if you will, of sections 1 through 3.